So we are on the third topic of the Unit 5, which is about the mantle. So for the objectives in this lesson, the students are expected to first describe the characteristic and layers of mantle. Second one, explain how seismic waves are used to differentiate layers of the mantle. Okay. So let's go to the different characteristic of the mantle. Alright, so the mantle makes up about 84% of the Earth's total volume. It is located between the crust and the core. So bali naa siya sa in the middle of the crust and the core, which is about 2,900 kilometers deep. The boundary between the crust and the mantle is the Mohorovicic discontinuity. So before ka makaabot sa mantle, nato ginatawag na boundary among the layers of crust and the mantle, and that is the Mohorovicic discontinuity. Meanwhile, Gothenburg discontinuity is located between the mantle and the core. So bali na apoy boundary that exists between the mantle and the core. So before ka makaabot sa mantle, before ka makaabot sa core, na boundary between these layers, the core and the mantle. And that is usually referred to as the Gothenburg discontinuity. Furthermore, the composition of mantle is mostly silicates. Silicates are considered as the largest group of rock-forming minerals which contain different ratios of silicon and oxygen. Examples of silicates include olivine, pyroxene, and garnet. So other major types of mineral located in the mantle include pericles, the magnesium oxide, and the wostite or the iron oxide. So ga-mention na po na ko ni siya in a class or in the previous discussion. In line with this, peridotite is the igneous rock found in the mantle. Okay, so peridotite class is the type of igneous rock found in the mantle. In fact, peridotite synolith was used to determine the composition of Earth's layer. As this rock forms, it collects samples from its surrounding area. So bali yung ginamagnet ang mga surrounding na mga materials sa iyang palibot. Hence, as it goes up to the surface, it contains several minerals and other fragments which are useful in tracing the characteristic of the areas where it originated and passed through. Additionally, there are other processes which help in analyzing the characteristic of Earth, such as studying volcanoes and hotspots. So, hotspots are areas where hot column of material from the mantle are ejected. So this is what we called as the mantle convection. Okay, so moreover, the temperature of the Earth's interior increases with depth. So as you go deeper, nag-increase ang iyang temperature. The rate of increase in temperature with respect to the depth, so ang kakusgon daw or ang kataason daw sa temperature with respect to the length of its depth or sa iyang kailalumon is called as geothermal gradient. So as you go deeper, mas mataas ang temperature. At the first 100 kilometer, the gradient is around 15 degrees to 30 degrees Celsius per kilometer. This temperature gradient drops off through the mantle and increases quickly at the base of the mantle. Kasi nga, padulong naman ka sa core, and among all layers of the earth, core has the highest temperature. Additionally, there are different processes which happens in the mantle. The process by which the mantle move as it transfers heat from the core to the lithosphere is called as the mantle convection. This involves convection currents formed from the upward and downward motions of the materials caused by the difference in temperature. In convection, warm materials rises while cold materials sinks due to the density difference. Convection currents transfer the heat to the lithosphere through hotspots and move other denser and cooler materials from the lithosphere to the core boundary through the process of subduction. So, balik class, ang mantle convection kay ano lang siya kanagong. It is a process of transferring the energy coming from the core, ipagawas to ni core. So, before ito moabot sa crust, kato siya nga energy, magikan to siya specifically sa core, which is then transferred to the mantle. Tapos, kana siya na energy, ma-relay siya gikan sa mantle, padulong sa asthenosphere, and then dito na sa lithosphere, tapos sa crust. But before na siya mahitabo, or before mahitabo na siya na mechanism, there is continuously an upward and downward motions of the materials nga mahitabo, especially if there is a difference in temperature among the materials on the different layers of the earth. Kasi nga sa convection mong good class, the warm materials, it rises. So, bali, mupataas ang mga warm materials, tapos katong mga bugnaw na mga materials, it will sink. And that is mainly due to the density difference. Kasi nga, mas mabigat yung colder materials compared to warmer or hotter materials. Aside from that, so since there is a transfer of heat nga gikan sa core padulong sa lithosphere, which is mogawas siya through hotspot or kadtong hotspot areas where a column of material from the mantle are ejected. So bali mo ra siya gap between plates na bali nag-slice ang duha ka plates, tapos sa tunga sa ila na ay gap nga nabilin. So dito mo gawas ang mga hot materials coming from the mantle. So that is on the other way for convection currents to occur. There is a movement of hot and colder materials, and aside from that, when these dense and cool materials also comes to the lithosphere, katong mga bugnaw class ng mga materials, mag-subduct to siya. When you say subduct, mo pa ilalong, bali mo siya malubong. And that's because they are mainly denser, or these materials are colder and dense siya. So that means mas mo paubos siya, or mas masapawan mo siya another materials nga mas gaan pa siya. So that means mas ma-expose na po siya dito sa duol sa core. So that means siya na po ang muinit. Yan po, kato na po na sa ibabaw sa yahamo na po to ang mubugnaw. We're going na ay transfer of heat. And that is really the main point for mantle convection. there is a transfer of heat from the core to the lithosphere. With this, it can be inferred that the Earth has a heat engine due to the mantle convection. Kasi nga, without mantle convection class, dili possible na ma-relay ang energy coming from the core padulong sa lithosphere, wherein heat is released to the ridges and collected to the subduction zone. The force that causes the warm and less dense materials to force itself up through a ridge is known as the ridge push. So, ang force daw nga maoy hinungdan nganong ang mga warm and mga less dense material or lighter materials magpataas or force itself up or mas mo pataas siya or mas mo ano good siya kanang mas mo ano siya kanang mo mas i-choose good niya nga mas mo taas ang yang direction, and that's because of the force known as ridge push. Kasi nga thinking that these materials are or have warm temperature and they are less dense, so that means mas mupataas jud siya compared sa mga colder and denser materials. On the other hand, slab pull is a pulling force. So bari siya ang force nga mobirang. Kung kanina sa ridge push, siya ang force nga mo push sa mga lighter materials and warm materials to go upward. Itong si slab push, siya naman yung force na mo pull the materials downward. So, slab pull is a pulling force. So, mubira siya, kusog siya mubira, which causes the oceanic plates to move downward at subduction zones due to difference in density as well as the effect of gravity. These forces facilitate material cycling in the mantle through the help of mantle convection. So, morag na siya interchange, or there is an interchange of movements between the warmer materials, the colder materials, the lighter materials, and also the denser materials. So, let us consider this diagram here. So, when we're talking about ridge push, so since it is a force that pushes the warm and light materials to go upward, so ang mahitabo dira is a mid-ocean ridge. So for example, this is a plate, or this is a tectonic plates that diverge or nag-separate ways sila. So, pag separate ways nila, naay gap nga nahitabo sa tunga. Dito. So, the magma or the mantle need to fill in those gaps. Kay dili man pwede nga walay mo puli ato kay kuan man siya. I mean, everything needs to be replaced, especially on the layers of the earth. So the mantle since mantle has this mantle convections, so when these two plates diverge or separate in ways, so naay mo puli na rising magma. And the reason for this rising magma is the ridge push, since it is a force that pushes these warm and denser materials to go upward. Now, slab pull, it is a force that pulls the cold and dense materials to subduct or to go downward, especially itong subduction zone. Kay diri man mahitabo sa subduction zone ang ginatawag nato nga subduction. So diri ma-form ang trench. So never ma-form diri nga trench. Lahi man gud diri sa mid-ocean ridge kay mura siya naay ma-form after man gud magawas ni si rising magma, mura siya naay ma-form na mga mountain sa dagat. Diri sa trench lahi pod ang ma-form dira mura gyapon siya naay bugdo gamay na mga kuan kay since na may mag-interchange na mga sana materials good. Alright. So next one is the layers of the mantle and the seismic waves. So mantle is subdivided into different layers as revealed by the seismic wave velocity studies. Body waves are seismic waves that can travel through Earth's interior and can be categorized into primary waves or P waves, which can travel both in solid and liquids. Meanwhile, secondary or S waves is limited to solid media only. Diba? I've mentioned a while ago that seismic waves, there are different types of seismic waves, and actually, merong seismic waves na maka-travel between two kinds of medium, just like solid and liquid. And that pertains to P waves or the primary waves because they're the one who can travel both of those mediums. On the other hand, secondary waves or S waves, it can only travel to solid media or solid medium. Additionally, the mechanical properties of the medium directly affect the wave velocity or ang kapaspason o ang kakusgon sa movement sa isa ka seismic waves. Compact and rigid material which are located on the crust, on the lithosphere, and on the inner core makes the waves propagate faster. So, mas paspas mo move ang waves or ang seismic waves under compact and rigid material. On the other hand, softer material or yung mga soft na mga material, it causes the waves to slow down. So, mas muhinay na siya diri. Okay, so let us consider this figure down. So these are example of the movement of the P waves and the S wave. So let us take a look first on tawag doon, P waves. So P waves, so si P waves nakapenetrate siya class. Nakapenetrate siya on the crust, on the lithosphere, and on the asthenosphere. I mean, dirian na mga layer, kanang padulong na siya sa manto. Then, niabot pa gani si P wave sa inner core. Diria. However, since considering manggod nga si P waves, it can travel both to solid and liquid media. So, therefore, it is really possible nga sa P wave moabot until inner core. Since even though si outer core liquid siya, maka-travel man gyapon na si P waves. On the other hand, si seismic waves, secondary waves or the S waves travels only up to the mantle. So by just looking up here, This one. So, since mao man siya si S waves, no, diri lang siya taman. Wala na siya niabot sa outer core. And that's because outer core is mainly made up of liquefied nickel and iron. So, therefore, dili siya possible na mo travel through liquid medium. Since ano lang man siya, pang solid media lang man siya. So, si S waves dili siya ingana kakusog. Dili ingana kakusog ang energy ni solid, ni seismic, ni secondary, sorry. Dili ingana kakusog ang energy ni secondary waves to penetrate the liquid medium. Compared man good kay primary wave nga tremendous jud ang energy na iyahang ginadala. That is why it can penetrate both to solid and liquid medium. So here in figure 12, both P wave and S wave increase in velocity as they go through tightly compressed rocks in the mantle. So notice that P wave slowed down and the S wave stop. Stop bitaw si S wave class. Stop si S wave as it reached the outer core and inner core. Tawa. Diba si S waves di ara siya tama na point, while si P waves niabot siya diri ang point. So secondary wave was not able to penetrate the outer core since it is in liquid form. Investigations in the velocity of these waves as they travel towards Earth's interior showed that there was a decrease in velocity on the upper part of the mantle and an increase in velocity on the lower part. This finding suggests that the mantle could be divided into upper plastic and lower solid regions. That is why nagavary pod ang velocity ani ng mga waves because naay layer sa Earth na paspas move ang velocity sa isa ka wave tapos naapoy layer nga dili mo slow down ang velocity ni seismic waves. Okay. So the upper part of the mantle is not uniform. It is rigid. Its rigid uppermost layer is similar to the crust. Together with the crust, its layer makes up the lithosphere. So yung uppermost layer ni mantle together with the crust, that makes up lithosphere. The asthenosphere is the denser part of the mantle located below the lithosphere. In this layer, the materials are more plastic and flow slowly. The temperature in asthenosphere is very high, causing the softening and partial melting of the rocks. This allowed the asthenosphere to exhibit the ability to flow slowly in response to stress, which is associated with ductile or plastic formation. Kanagong plastic siya class nga dali siya ma-deform pero dili siya magbulag. So mo respond siya sa stress or mo respond siya og mga kabag-uhan sa palibot pero dili siya nga ma-break down or ma-deform, but instead mag-join gyapon sila together with the other materials or with the other components tapos continuously flowing lang gyapon siya. Seismic velocities are reduced by this weaker layer, resulting in the low velocity zone at the boundary of the lithosphere and asthenosphere. A transition zone is a zone where rocks undergo a complete change. Instead of being melted, the rock's crystalline structure change and the rocks become denser. At the base of the transition zone, the strong mineral perovskite forms and marks the start of the mesosphere. So, ito yung transition zone. Dito na portion. So, si asthenosphere Diri na portion. Then sa lithosphere, diri apod. So, asthenosphere ang naay plastic physical state. Okay, so the mesosphere is referred to as the lower mantle, which lies below the asthenosphere. So, baba lang ni siya sa asthenosphere. In this region, the materials are semi-solid. Perovskite, peroclase, magnesium, wostite, stishovite, almenite, and ferrite are the major minerals found in this layer. Additionally, the boundary between the asthenosphere and the mesosphere is the 660-kilometer discontinuity. So this is the end discussion for the topic 3 of the Unit 5